Welcome back, sixth graders. This is lesson 4 on parallelograms, okay? So this first part, it just says investigate the features and the area of a parallelogram. So if we look at this, it tells you in the directions that A, B, and C are parallelograms. D, E, and F are not parallelograms. So let's go through and see what makes a parallelogram and what doesn't make a parallelogram, okay? So it just says study the examples. So what do you notice about them? And then question 1 down here, it says the number of sides that a parallelogram has. Well, it's telling me these 3 are parallelograms. This has 4 sides, this has 4 sides, and this has 4 sides. So I'm going to conclude that a parallelogram has 4 sides, okay? So down here I would write it has 4 sides. All right, but I'm looking up here. This has 1, 2, 3, 4 sides. Okay, so this has 4 sides, but it's not a parallelogram. Okay, this has 1, 2, 3, 4, 5, 6 sides. And then this one also has 4 sides. So if we just did it by number of sides, then that would be a parallelogram and that would be a parallelogram, but we know they're not. It's telling us they're not, okay? So we do know that it has 4 sides. All right, so here's the clue on it's going to be different. What do you notice about the opposite sides of the parallelogram? In other words, on these shapes, what about this side and this side, okay? This side and this side, and the opposite would be just the opposite sides. And if I did the other 2 opposite sides, this side and this side and this side are opposite, and this side and this side are opposite. What do I notice about those? Well, what's literally in the word parallelogram? They are equal distance from each other, which means they are parallel, okay? So that's what makes it a parallelogram, that it's a 4-sided figure and 2 pairs of opposite sides. So this side and this side are parallel to each other. This side and this side are parallel to each other. And all that means is that they're equal distance apart, okay? They will never touch. So this side and this side were parallel, this side and this side, okay? So I know that the opposite sides of a parallelogram are parallel. And if I use that reasoning to go back, that's why this one is not a parallelogram. Because this side obviously is not parallel to that's on a straight up and down, and that's on a slant. Those 2 sides are not parallel, and these 2 sides are not parallel, okay? So I have to have both. So this makes it not a parallelogram, and this also makes it not a parallelogram, okay? Well, this didn't fit my first criteria, which means it had to have 4 sides. So that guy was out right away. This one, if I look at it, this side and this side are parallel, okay? But this side is not parallel to this side. That is why that's not a parallelogram, okay? So this is actually called a trapezoid. If one side is just parallel, or one pair is parallel, that's a trapezoid. When you have one pair of parallel lines and not the other. This is a 6-sided figure that's called a hexagon. And then this is 4-sided figure. It is just a 4-sided figure. It doesn't have any special qualities. It's just a quadrilateral. That just means 4-sided. Literally means 4-sided, okay? All right, so what do we notice about the opposite angles of a parallelogram? So we're just going to look at these 3 because we know they're parallelograms. So it's saying opposite angles. This angle measure and this angle measure. They look like they're equal, don't they? And then I would look at the other 2 opposite angle measures. This angle measure and this angle measure, okay? So it looks like the opposite angles are congruent is the equal word for geometry. It means it's similar and equal. So these 2 look like they're exactly the same, and these 2 look like they're exactly the same. If I look at B, it's a rectangle, so all 4 of them are 90 degrees, okay? So they're all the same. which is part of a definition of a rectangle. See how these aren't all the same. That's why this is not a rectangle or a square. This has to have 90-degree angles to be a rectangle. And then this is just a square kind of on its side, but all the angles are 90 degrees, okay? So for a parallelogram, the opposite angles of a parallelogram are congruent. That means they are equal in measure. Okay? So if I looked at these opposites, they're going to be equal because they're all 90 degrees. So these opposites and these, so it still fits that definition, okay? And then these opposites and these opposites. So that's what makes a parallelogram, okay? All right, let's move on. Okay, area of a parallelogram. So we're going to do this a little different. You actually have to think about how you would decompose this, okay? There is a formula for the area of a parallelogram, and it is base times height. It's the exact same as a rectangle, okay? Except for I have to think about what the base and the height are. So what I would do is I'm actually, if I want to take this off, if I took off this triangle, okay, I'm going to get rid of that triangle. I'm going to flip it and slide it over here. Okay, so what I'm really doing is getting rid of this. I'm actually not getting rid of it, I'm moving it. So what I did is I took this and I just shifted it over that way. So now I have one big rectangle. So I'm just going to highlight. Okay, so we actually just took this part, slid it over. And then if I want to find the area of this, I would just do my base times height, or length times width, and I'm going to count just these squares. So I would do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's actually a square. No. And it is 36 units squared. Okay? All right, so if we look at this one, again, I want to make it into a rectangle. So I'm going to just take one of my corners and go up, and I'm going to take this triangle, move it over here. So this 1, 2, 3, 4, 5 would go 1, 2, 3, 4, 5 and down. Did I do enough? Yeah, sorry. And then I get my highlighter, this rectangle. And then if I want to find the area of this, I do base times height. My base now is 1, 2, 3, 4, 5, 6. My height is 1, 2, 3. And I get 18 units squared. Okay? So I'm doing the same thing we did on the last thing and just showing you how a parallelogram works. Okay? Now, we're going to, there is a formula for parallelogram that is base times height. It is the exact same thing. Only the height has to be how tall it is. My base is going to stay the same. My height is going to be how tall it is, not how long one of these sides is. Does that make sense? Because when I move this over, I still have the same base. I have 1, 2, 3, 4, 5, 6, like I had in the original one. I still have 1, 2, 3, 4, 5, 6. Only when I moved it over, my height becomes from here to here. Okay? Or I could say from here to here. So my height has to be how tall it is. And that's what you'll do eventually, is you won't be deconstructing them. You would just do the base times the height, how tall it is. Okay? Your height has to be perpendicular to your base. Let's write that down because that's really important. Height, and that just means they meet at a 90-degree angle. Must be perpendicular to the base. And that just means they meet at a 90-degree angle. So all rectangles fit that, right? Parallelograms, not necessarily right away when you look at it, but rectangles are already set up that way. Okay, let's move on. So same thing here. I want to figure out how can I make this into a rectangle? Well, I'm going to go from one of my corners down. So I would take this and I would move it over here. Okay, so that now I have my rectangle because I moved this, that's gone. Okay, and then I just do my base times my height. I have 1, 2, 3 times 1, 2, 3, 4, 5, and I get 15. Remember, you got to put units in. If it was inches, I'd write inches squared, but it isn't, it's units. Okay, this one looks a little tricky because it's going to be really hard to know what to move, okay? Because this parallelogram is very long and skinny. So what I might do is I would probably try to find the whole thing and then subtract out the two triangles. Does that make sense? So let's do this. We're going to make one big rectangle. Okay? And then I have two equal triangles then, and I'm going to subtract out those triangles. So I'm going to find the area of the shape, big rectangle. So I would go 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3, 4, 5, 6. That gives me 54 units squared. All right, if I look at the triangles, okay, this triangle right here and this triangle are equal. They have the same base and height, so I have 1, so I have to count the whole thing, 1, 2, 3, 4, 5, 6, 7, and then it would be 1, 2, 3, 4, 5, 6, okay? And if I look at the same thing, 1, 2, 3, 4, 5, 6, 7, and 6, okay? So what I'm going to do is I'm going to say, well, if I put two triangles together, so I'm going to get rid of that and push my two triangles together to make a rectangle, that would be 7 times 6. So 7 times 6, which is 42 units squared. That is your two triangles together, right? So it's this triangle and this triangle. Okay, so I know that the area of the whole thing is 54. I know that the area of the two triangles, because I pushed them together to make a rectangle, just kind of got rid of that place, was 42. I'm going to subtract them. So I would do 4 minus 2 is 2. So this whole thing is 12 units squared. So the shaded area is 12 units squared. Okay? So that's one way I could do it. And I can do that with any of them. I could have made a big rectangle here and subtracted out the triangles too. Something like this, I kind of need to do that because I can't really tell how many, what the base and the height are. Okay, I can tell that that's 2 across. I don't really know what the height is. Okay, so, but if I use my formula, base times height, 2 times the height has to be how tall it is. It's this tall, which was 6. That's how I got 12 as well. All right, so the bottom one, we don't have squares. So let's go through this. All right, so again, it's telling me that if I took this triangle, my dogs are barking downstairs, and I moved it over here, okay? I'm gonna make a rectangle. That would be 6 times 4. This part is 6 because I took this off of here. So whatever this part is, I just added the exact same thing on. So it's 6, but the height is 4. So this would be 6 times 4, which is 24 units squared. Okay, here's a really good example of why when we do base times height on a parallelogram, you can always do that. Why the height is not 4.5. Because when I move this triangle over, my height is 4. It's how tall it is, okay? So my base, I could have also done this as my base of 6. So I'm going to kind of redraw this, okay? So if this was 6 and it tells me my height, which remember has to be 90 degrees, is 4, I'm really just multiplying my base times my height. I don't have to move the triangle, but I can. That's how I get that, okay? So that's how I get 24 units squared. Oops. All right. So they're pretty easy. They're just like rectangles, same formula, except for you got to remember what the height is. And if you forget that, then you just move over the triangle and make a rectangle. All right. There's not too much. Oops. That's pretty much all that's in this section is about parallelogram. So let's just review it really quick. So it says a parallelogram is a quadrilateral, which means it has 4 sides. These 2 sides are parallel, these 2 sides are parallel. This angle is equal to that angle has to be equal to that angle, okay? This also tells me there are several strategies for finding the area. You can decompose and move it. So here was your original. They took this triangle off, scooched it over there to make a rectangle, okay? So it's just showing me a couple different ways I could do that. So I have a rectangle. I can enclose the parallelogram and subtract out the 2 triangles. That's what we do, that long, narrow one. So what they did here is they said, okay, I'm gonna make this into a rectangle. Then I'm gonna subtract out these triangles, okay? Which together make a rectangle. So both of the ways work. Sometimes one way is easier than the other way, especially if you have something like this. It's way easier to enclose it than it is to try to move the triangles around, because that's just tough when it's not showing you the angle. And remember, the formula is still base times height. So if I were doing this one right here, my base was 2, my height has to be how tall it is. So my height is actually outside of my base. My height was 1, 2, 3, 4, 5, 6. So it's 2 times 6, which is 12. Okay, so there's many ways to do this, but hopefully this will help you move along with trapezoids. I will see you soon. Bye.